Well, we're going to take a little break from the calculus and we're going to go back to college algebra. Back in the day, when we were doing the college of the algebra, one of the things that you had to learn how to do is solving inequalities. Do I remember how to do this? Do I remember how to do this right here? Solving the big bad inequality?
Kind of.
Cool. So let's start with a simple one, and then let's try one that's a little harder. So let's say I have x minus 4 multiplied by x plus 3 right here, and it is greater than or equal to 0. And I am trying to solve this inequality. I'm trying to find when is this graph right here greater than 0, when this function right here greater than 0. Well, your first step is to find the zeros. You go to each factor. Say, for example, x minus 4. You set it equal to 0, and you solve for x. X plus 3 is equal to 0. Subtract 2 from both sides. X must be negative 3. That's my first step right here. We find the zeros because those are the key points when we can figure out what the function is doing. Yes?
Yes.
Cool. Now the next thing is we have to set up what's called a sign chart. A sign chart is the method that we will use to solve the problem. So the sign chart will take us through all the steps, excuse me, that we got to go through to help us get ourselves to our answer. So I will draw my number line. Somewhere on this number line is the value of negative 3, and then somewhere is the value of 4. I will then split the graph at negative 3, and then split the graph at 4. Okay? That, if I have a number line right here and I split it right here into 3, this graph, if I cut it twice, it splits into 3 regions, correct? The first region runs from negative infinity to negative 3, square bracket. Where does the second region run from? Anybody?
Negative 3 to 4.
Positive infinity. Or I'm on the wrong one.
And what's the last one go to?
4 to positive infinity.
4 to positive infinity right here. Now, y'all remember your rules of inequalities, right? When you have an inequality that looks like this, we use square brackets, correct? If it was a strict inequality, everything would be parentheses, yes? That's a very important point. In the less than or equal to, the greater than equal to, sorry, is causing us to use square brackets instead of parentheses, right? And of course, you have to remember that infinity always takes on parentheses itself. Any questions there? Okay, cool. So with that being said, I now set up, so I put over here my 2 factors, wrong color. My first factor was x minus 4. And my second factor right here is x plus 3 right here. And I have to determine the sign of those factors in each of the regions. So my question to you is, if I take a number between negative infinity and negative 3, and I plug it into this factor right here, will the answer be positive or will the answer be negative?
Can you repeat that?
If I take any number between negative infinity and negative 3, and I plug it into x minus 4, will my answer be negative or will my answer be positive?
Negative.
Negative.
And to help us out, I'll just pick one of the numbers. Doesn't matter one, negative 5 in this region. Negative 5 minus 4 is negative 9. I do it again for the other one. Negative 5 plus 3 is negative 2. And so that right here is negative. Questions there? Then I multiply my answers. What's a negative number times a negative number result in?
A positive.
And so this first region is a positive region. So give me a number between -3 and +4.
2.
2.
If I plug 2 in the first one, 2 minus 4 is -2, correct? If I take 2 and I plug it into the second one right here, 2 plus 3 is +5, yes? And then I multiply a negative by a positive is a negative, so this is a negative region. Have I lost anybody? Everyone knows how I'm getting these signs? They are crucial to getting to our answer. Okay, cool. And give me a number between 4 and infinity.
7.
So our test point of 7. 7 minus 4 is +3. 7 plus 3 is 10. I just need the sign. I don't actually need the number. 7 plus 3 is +10. And then a positive times a positive results in a positive answer once again. You know, as they say in the business, return of the Mac. Questions there? So with that being said, I go back to my problem. My problem is saying, when is this function right here greater than or equal to 0? Well, what kind of numbers are greater than 0? Positive numbers or negative numbers?
All positive numbers.
Positive numbers. So where are the positive regions right here in this problem? The first positive region extends from -infinity to -3. And then the second positive region extends from 4 to infinity, correct?
Yes.
Therefore, that is my answer. That's the solution to the problem. When is x minus 4 times x plus 3 positive greater than or equal to 0 is going to be -infinity to -3, and the u to represent union, and 4 to infinity. Questions there?